Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning to all of you. Alright, so today we discuss about the tutorial 2. Tutorial 2 will be logic gates, Boolean expression and logic gates. Alright, so on the tutorial 2, as you can see I already share this in the screen. So you can see here, so we have around 24. Okay, we have 24 questions. So maybe for today I just maybe I focus until half of this question, so half, maybe 1 hour section for tutorial 2, then we continue for the next, okay, for the next part 2 part tutorial 2 part 2. Right, so if you see this one, the question number 1. Okay, alright. So question number 1, we withdraw the output waveform for the O gate of the figure 2.1. Figure 2.1. So you have to get the X here. So the output X here. So the output is actually is the so in the Boolean expression, the output of X is equals to A plus B plus C, right? Right. So maybe you can draw the truth table, the truth table for this output. Okay, for example, we have a, okay, A, B, C, and then we have the X. Okay, so we have three input, three variable. That means we have 2 power 3 equals to 8. That means we have 8 sequence. Okay, starting from 0, 0, 0. That means from decimal is a 0, 0, 0, 0. Okay, this is the decimal. Okay, in decimal, right, until 7. Okay, until 7. Okay, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, sorry, 1, 1, 0, okay, 1, 1, 1, okay, which means this one will be 1, 2 until, okay, this one will be 7. So this is decimal, this is the binary. Alright, so as you know, the O, that means the operation is the we have to add, we have to add. This means we have to add here, add here. So this means input A plus B plus C lah. So this means here will be 0, 0, 0. Okay, this one 1, 1, 1, 1, 1, 1, 1. Okay, all the one. Only 0, 0, 0. The output will be 0. So as you can see here, so then we have to draw lah. We have to draw the output. So which one, if we have the input 0, 0, 0, that means the output 0 lah. The rest will be 1. So the rest will be 1. Okay, so 0, 0, 1. Okay, okay, this part. Okay, in this part we have a 0. Okay, until this part. Until this part. Okay, the rest is 1. Okay, until this part we have 0. Because 0, 0, 0. Okay, and then okay, so this one, another one here. Okay, it's a 0, right? And then until this one, right? So we have another sorry, we have another 0 here. Okay, this one, right? Another 0 here. Okay. Okay. So we have another 0 here. Okay, so the and last one is the 1 until at the end here. Okay, 0, 0, 0. Okay, this one and another one here. Okay, so this is the X. This one 0. Okay, so this is the output for get. Okay, so next we go for the question number 2. Change the OR gate in the figure 2.1 to the AND gate. So this one we change to AND gate. So this one X. So X. So we have A, B, C. A, B, C. So the output for AND will be multiplication. So A dot B dot C. Right. So first step, as similar like question number 1, maybe you can first develop the truth table. Okay, that means we have 8 sequence from 0 to 7, and then just okay, so you have to multiply lah. Okay, multiply, so get the output here. So will be, for example, assume this one similar like this one, but this one, okay, this one we consider this, we consider as a O, this is considered as N. Okay, so multiply, okay, this is a 0, okay, 0, 0, 0, 0, 0, 0, 1. Okay, 1 multiplied by 1, 1. Okay, so the rest is a 0. Only 1, 1, 1 will be 1. Okay, so you can check lah. Right, so which one we have 1, 1, 1, 1 will be 1. The rest is the 0. Okay, the rest is the 0. That's why you have to draw lah. Okay, draw the output. So maybe so this one I just give a answer. So something like this. Okay, on the we have two part. Okay, we have two part on the one. Okay, this one 0, 1. So you can check So this is the answer for A. And then B, draw the output waveform if A inputs is permanently shorted to the ground. So that means is the 0. Okay, you can draw 0. Okay, you can draw the 0. Okay, because of the ground, ground automatically okay, so will be 0 So and then for C, draw the output waveform if A is permanently shorted to the 5 volts. Okay, so this means 5 volt is 1. A is the 1. That means A here will be only 1. Okay, second B is the shorted to the ground, so the B will be ground. So you can set 0. Okay, so and then that's the output then you can use this two table to draw the output waveform. Okay, so maybe I go for the question number 3. Write the Boolean expression for the output X in the figure 2.2. Determine the value for X of X for all possible input condition and list the value in the truth table. Okay, so you have to get the outputs output X in the Boolean expression. Okay, so as you know here, so we go here. So this is A bar, this is B bar. So this one will be A bar plus B bar. Then this is A bar plus B bar. Okay, so this one will be here will be B, and this one will be C. So multiply. Okay, so A bar plus B bar dot B C. Okay, something like this or you can do like this. Okay, so that's the output Boolean expression for X here. So maybe I can try to another figure 2.2b. So this one will be okay, A bar, this one B bar, this one will be C bar. Right, so this one will be A B bar, C bar. Okay, so this one will be C bar. Okay, this one will be B bar. And then what is this one will be A B bar C bar, and then this one will be B bar C bar C. So A bar B bar C. So this one will be add so A B bar C plus A B bar C plus A bar B bar D. Alright, so that is the output expression, Boolean expression for the output X for figure 2.2b. Okay. So actually this one you have to develop the truth table Okay, the truth table for the output. So the possible. Okay, so this one we have 3 inputs. Okay, we have 3 inputs. That means the sequence is the 8. So you can start So for example A B C, right? 0 0 0 0 0 1. Okay, 0 1 0 0 1 1 1 0 0 0 1 0 1 1. Okay, 1 1 0 1 1 1. Okay, so this is the X here. Right, so you can check So the answer will be okay, 0 0 0 0 0 0 0 1. Okay, so that's the truth table truth table for the B for the A lah. Right, so you can try for the output for B. You have to develop the truth table. So this one we have 1, 2, 3, 4. We have 4 input variable. That means 2 power 4. That's 16 sequence lah. That means start from 0 to 15. Okay. So A, B, C, D is 0, 0, 0, 0, 0, 0, 0, 1 until then you can get 1, 1, 1, 1 lah. Starting on the decimal is this is decimal is the 0 until this one will be 15 lah. So this is the decimal, this is the binary lah. Then this is actually the output of X. Okay, so this one you can you can try you can try this one. Right. Okay, next we go for the question number 4. For each of the following expression, construct the corresponding logic circuit. Okay, logic circuit, digital logic circuit using AND, OR, and inverter lah. Alright, so this is the basic basic logic gate. We have AND, OR, and NOT or inverter. So we have here lah. So this one is the AND, OR, and another one is the NOT. Okay, so this is the basic logic gate that you have to draw lah. Okay, so this one right. So for example here, so for A, so we have the AND here. So we have the AND lah. Okay, and before AND we have the inverter lah. So we have inverter here. Okay, maybe the output will be, so this one normally my style I do from the backward from the output to the input for construct the logic circuit that's my style. So up to you. You can also start from the input to the output my style. So I have to develop from the output to the input So here, so C plus D. Okay, this one will be right. So this one okay. Alright, so I start here. So this one will be A, B, C plus D. Alright, so we have N here. Okay, we have N. Okay, this one will be okay. A, B. This one we have the C plus D. Alright, so C, N, and B. So we have another N here. Okay, this one A, this one B. Okay, this one we have the not all. Okay, all. Right. So ABC and D. So this is the the logic circuit for the question for B for question for B. Sorry. Okay. So for the B, right? So for B, okay. For example, we have this one So we have a O We have a O. So maybe I start here. Okay. So okay, for we have the O gate here. So the output N plus N bar. Okay, but N plus PQ. Okay. So this one will be N plus N bar. Right, so this one will be P bar Q. Right, so this one you have the NOT gate here. Right, and then this one will be N plus N. Okay, so this is a O. Gate is the M and M. So this one another. Yeah. Alright, so this one we have the N gate here. So N gate okay, N gate. So this is the P and Q, this P bar. So we have another one here. So this is P and this is another one Q. Alright, so this is the logic circuit logic circuit for the question for B. Okay, for the for C, for example, we have a normally we have the N here, so we have N here. The output will be N. Normally I do like this so it can up to you which one you are familiar. And N P plus N bar. Okay, so I start here. So we know we have to input here and N. Okay, so another one we have the P plus N bar. Alright, so this one we have another one is N gate here. So between M and N here. Okay, this one we have P and N. Okay, so we have the OR gate here. Okay, this one will be we declare as the N bar. Okay, this one will be P lah. Alright, so this one we have another one not here. Alright, so it will be like this. Okay, for the equation 4C lah. So the rest you can try. The rest for D, E, and F you can try. Okay, so you can DIY. Okay, so next we proceed for the question number 5. Okay, so refer the timing diagram in the figure 2.3. Develop the truth table and write the Boolean expression in minimum SOP lah, SOP form. Alright, so you have to develop the truth table lah. The truth table. So you can see this one. Okay, the output here. So A, B, C, and then the output will be Y lah. So first we just put the sequence lah. This is a standard 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so this means from 0 to 7 lah. Right, so the output here, so you can check lah, 0, 0, 0 will be 0, and then 0, 0, 1, okay, fine lah, 0, 0, 1, okay. So I just skip, I just skip this one, so the answer will be 1, 1, 1, 0, 1, 1, 0. So that's the output from based on this one lah, okay, based on this the timing diagram, the timing diagram, okay, right, and then you have to minimum, okay, minimum Boolean expression lah. Okay, minimum Boolean expression, that means first you can use the K-map or you can use the, okay, so this actually this is the output. Okay, so you can use the K-map to simplify the expression. For example, here will be A. Now we use the SOP, so this one will be A bar, B bar, C for this one, and then this one will be A bar, B, C bar. Then this one will be A bar, B, C lah. Alright, and then you can simplify. Okay, so this is another technique. So the simple method you can use the K-map lah. Alright, use the K-map. Okay, so for example, the K-map here. Use the K-map. Okay, so for example, this one A, B, and this is C. Alright, so the K-map, make sure you have to follow the sequence. For example, this one is 0, 1. Okay, this one for A, B, 0, 0, 0, 1, 1, 1, and 0. Okay, make sure this one will be start on 1, 1 and 1, 0 lah. So and then you can plot based on this truth table. Alright, so we have the 0, 1, okay, 1, 1, 0, 1, then 0. Okay, so okay, now we have to grouping lah. So that you have to remember. So for grouping for the K-map, first priority. Now we have 8. We have 8 possibility lah. The first grouping, but we cannot because we have 0, 0, 0 here. So second we reduce to 4. So also 4 cannot lah. So you cannot here 4. You cannot here 4. Cannot here 4 because of we have the 0. So next we have to go for grouping 2 lah. So okay, grouping 2 we have here 1. Okay. Okay, also can share this one, another one. Alright, so we have 3 here. And then, so if this one cannot share with others, so this one will be only one, only one. Then you have to write the output lah. The output Y equals to okay, A bar C plus A bar B plus BC plus A B C. Alright, so make sure you have to know how to read from this one. For example, for this only single, so we have the A, okay, here A B bar multiplied by C bar. So that's why the answer will be here. Okay, right. So this is the simplified lah from actually from this one. So this one we have A B bar C, and then another one we have A B C bar. Alright, so from this Boolean expression, so we can simplify into this one, okay, this one using, so you can use using the Boolean rules, or De Morgan, or you can use the gamut. For me, better use the gamut lah. Alright, so next we go for the question number 6. Apply the output, the input waveform of the figure 2.4 to no gate and draw the output waveform. Alright, so okay, so you have to know the output for no gate is the when output is 1, only when the input are 0. This means all the input are 0. This means the output will be 1. Right. So here, so we have this one. So we have output 0. This one, okay, 0, 0, 0. So alright. So okay, another one here. Okay, 0, 0, 0. So the rest is the okay, the rest is 0. Oh, sorry. The rest is 0. So this is the output. We can it as the X. Okay, so this is the output waveform. So as you have to know now. So from this one, you have to know the truth table for the NOR gate. So the output is 1. The output is 1. If the input, all the input is 0, 0, 0. Okay, for example, we have 3 inputs, so 0, 0, 0. So the output here will be 1. Okay, the rest will be 0. Okay, the rest will be 0. That's why the answer will be 0. Part this one because of 0, 0, 0. So this one will be 1. And figure that is 0, 0, 0. So it will be 1. Okay, so today's question number 6. Right, so next we go for the question 7. Okay, question 7. Write the expression of the figure 2.5 here and use it to determine the complete truth table. Okay, then apply the waveform of the figure. Okay, so this one will be wrong. 2. Okay, this one 2.4. This one, based on this input to the second input and draw the resulting output waveform. Alright, so first you can get the Boolean expression, the output for Boolean expression. For example, here we have the here is the A, B. So this one will be A plus B bar. Okay, we have B here, and then C bar here. So we have B plus C bar, the bar. Okay, this one we have the A plus B bar. Okay, multiplied by B plus C bar. Okay, from here. Okay, this one. Alright, so then okay, after then you can get the truth table lah. Okay, from this one, okay, for example, get the truth table. Okay, you can you have 3 inputs, so you can for example A, B, C, and then X. Okay, the X output. Okay, start from 0, 0, 0, 0, 0, 1 until 1, 1, 1, and then you can substitute to this equation lah. Okay, to the equation. Right, so to get the output here, for example, okay, this one will be 1, 0. Okay, the rest is the 1. The rest 1. The rest is 1. Okay, the rest is 1, 1, 1, 1. Okay, so this is the complete truth table truth table, and then you can draw the output waveform based on the this one based on the truth table here. Right, so then you can apply. Okay, this means on the question then you can apply the input. Okay, for example, okay, the sequence number 1, 0, 1, 0. Okay, 0, 1, 0 is 1. So that is the output. Okay, the output X is 1. Okay, 1. Okay, for example, 1. Then next here 1, 1. Okay, here 1, 1, 1. 1, 1, 1 is 1. So maybe right, so something like this until okay, this is some example. you can check the result lah, something like this. Okay, so this is the result based on this input for question number 7 so based on this input lah. Okay, next we go for the question number 8. Okay, question number 8 will be given the Boolean expression. Okay, so you have to draw the logic diagram without simplify the expression so this means no need to simplify you have to draw okay, so this one similar like question number number 4 number 4. So we can simplify it first. No need to simplify, sorry, you have to draw the output of logic circuit here. So maybe I just draw one example. So for example, we have a logic here. We go for n, then another logic here. So here we do n, and gate here, this one A, B. So we have another B, this one C. We have a inverter here, so go here, and then this one we have C. So that's the draw the logic diagram without simplify the expression. So then you have to redraw the circuit using the NOR gate so you have to convert. For example, this one we have already in the NOR gate, so no need so this one we have the AND gate, and this one we have NOR gate, and this one we have AND gate. This one no need so something like this. At the end you can get like this. Gate here, so we have another, this one will be same. Okay, this on this one will be same because of already this one already the using the NOR gate. Okay, this one we have another OR gate here, so we have another OR gate here. Right, so another one here. OR gate output here, OR gate here. Okay, and then this one we have the OR gate here. This one we have another OR gate here. This one for C, right? So and then this is for B. So B here. So for C we have another one for C. Okay, so continue this one. Okay, something like this. So this one actually we have another one here. Here on this part we have another NOR gate here. Okay. Then simplify the Boolean expressions and write in the post in the post form. Okay, so first you have to simplify. Okay, so that now we can use the De Morgan. Here you can use the De Morgan. So you have to remember for De Morgan, break the bar, change the operator Okay, break the bar, change the operator. For example, we break here. Okay, we break here. So one will be A plus B bar C here multiplied by B, another one here. Then you can separate again using the B. So they can do okay with break here. So will be A plus B double bar plus C bar. Okay, so this one will be cancelled out. Okay, multiplied by okay, so this one B double bar plus, okay, you stick here plus B bar. Okay, so this one will be cancelled out. So the output will be A plus B plus C bar multiplied by B plus D bar. Right, so this is the in the post form but it's not a standard okay, it's the standard, so you have to, for example, here we don't have the D element. Okay, here we don't have the A and you have the A and C, so you have to, but this is in the post form. Okay, the question is only the post form, but if the question one is you have to solve post standard form. Post standard form, that means all the element we have the all the Boolean expression here, we have the element lah. For example, we have the A, B, C, D, and this one also we have A, B, C, D lah. So just this one we have to, for example, just do one example here: A plus B plus C bar plus D, D. Right. So you can split by two lah: A, B, C bar plus D, A plus B plus C bar plus D bar. Alright. So this is the on this part lah, on this question. Then we can try this one. So this one you have to multiply by, first you have to, sorry, do not multiply, you have to add with A bar and C bar. Right. Actually this one is a zero. Okay, so this one is a zero. That's why. But in the post, okay, we have to, all the Boolean expression we have the element lah for the input variable. So we have the input variable, we have the four. Okay, we have A, B, C, D. So that means this one we have the element for input variable lah. We have the A, B, C, D, and also this one we have the A, B, C, D. Okay. Alright. So next we go for the question number 9. Okay, question number 9. Alright, question number 9 is the apply the De Morgan theorem. Apply the De Morgan theorem for each expression. Alright, so you have to remember lah, for the Boolean expression. So break the bar and change the operator. So for example, question 1, we break here, then change the operator lah. Okay, A plus B plus C. Okay, so this one so it's only one, only one. Okay. First. Okay. Alright. So this one we can break A bar plus B bar dot C bar. Alright. So this is the answer lah. Okay. That's the answer for 9. Then for 9B, okay, 9B, okay, so you have to maybe you can do separate lah. So you can solve this one first. So this one, okay, you have to break the bar, change the operator. So D double bar plus D bar. So will be D equals to D. So this one can cancel out. So E plus E bar. Alright. So this one, this part, okay. So we have to. Okay, because all the operator, so all the, okay, so we can draw like this. Okay, in this part we have A dot B double bar, A bar, C bar dot C bar, D double lah, okay, double bar. So this one cancel out, can cancel out. So A bar dot B B dot C bar dot D. Okay, then plus with B plus E bar. So that's the answer lah. Okay. Then for the questions 9C, okay, 9C, first you have to split here. Okay, split here. So okay, so break the bar here. So the operation will be plus here lah. And then you can do separate lah. So solve this one first, and then solve the second one, and then just plus the okay, so the solution for part 1 and plus the solution for part 2 here. Okay, similar like this one. Okay, similar like this one. Okay, first you have to refer to the upper bar here. So this one, so this one you have to break here. Alright, so we have to break here. Okay, there is one break, and then this operator will be changed to plus. Okay, the plus, and then actually this one will be double bar, so you can cancel out. Also this one will be double bar, so you can cancel out. So no need to simplify because it's only, okay, so the answer will be A bar plus B plus C plus D. Alright, plus plus, because I've already changed the operator, plus A B bar C bar D. Alright, so that is the answer lah. Okay, the answer for question 9B. Okay, so we go for the question 10. Okay, 10. Okay, so implement the logic circuit that has the expression x using the NOR gate and using the NAND gate lah. After that, determine the truth table of this circuit. Alright, so okay, so you have to develop lah. Okay, so we have NAND here, and the NAND gate here. Okay, the output is A B dot C plus D. Okay, so this one actually we have the another NOR gate here. Okay, so here, so this one will be C and B. Okay, this one C and B, and this one will be A. Another one is the B. Okay, something like this. Okay, so this is the square. Okay, this is A and this is B. Okay, something like this. This is it. And then we have to develop the truth table lah. Okay, so we have the we have four lah. We have A, B, C, D lah. So you can like this A, B, C, D, and the output is the you can declare as the X. Okay, starting from 0, 0, 0 until 1, 1, 1, 1. So you can apply to this Boolean expression to get the output X here. Okay, so the answer will be all the one. Okay, only we have we have 1, 1, 0, 0. We have a 0. The rest is 1. The rest is 1. Okay, the rest is 1. Okay, that's the answer. You can check after this. Okay, so next, I think we'll cover until 11 for the part 1. Then I will continue for the next okay, for 12 until 24. So this is part 1. Part 1. Okay, so we just cover until 11. So for the 11, using the Boolean algebra, simplify the each expression. Okay, alright, so you have to simplify this expression. So this one you have to use the rules or De Morgan. Alright, so for example, you can use the first you can use the De Morgan here. Alright, this part De Morgan, and then you can use the rules. Okay, for example, okay, for here, okay, I'll put here A B, okay, plus A. Okay, so this one bar dot C bar, okay, plus B B bar dot C bar. Okay, so this one actually is a 0. This one actually is a 0. B on the row B bar will be 0 lah. So multiply by C is a 0. So on the left, this one A B bar plus A B bar C. Okay, so you can simplify lah. So A B bar 1 multiplied by C bar. Okay, so actually everything plus 1 will be 1 lah. So this one will be 1. So at the end we can get this as the output lah. So this is the simplified lah. Simplified this expression Boolean algebra. So the answer will be A B bar for question 11. Question 11 here. And then for B, okay, 11B. So also you can first you can simplify using the De Morgan first. Okay, this one, this part. For example, okay, De Morgan, okay, A bar B C plus. Okay, we have to change here lah. Okay, so we be A bar B bar. Okay, multiply by C. Okay, C double bar here cancel out. Cancel out will be C. Okay, so this one A bar B bar C bar D. Alright, so this one you can simplify. Okay, so you can simplify to this one. Okay, you can simplify this one. So actually this one will be same. This one will be same. Okay, if for example you have A plus A, so will be A, the answer will be A. So this one only you can cancel out 1. So we have A B bar C plus A bar B bar C bar D. Alright, so you can simplify to this one. So this one A, okay, A bar B bar, right, C by A bar and C. Right, so C bar Okay, CD. Alright, so this one, okay. So this one, okay, this one we can only left C and D lah. So this one will be only we have the A bar, B bar. So we have the C plus D. Okay, because of this one will be one. Okay, so this one will be one. So you can check the row here. Check the row here. So and then the end you can expand this one. So A bar, B bar C plus A bar, B bar C. Alright, so this is the result for the answer for this one. Okay, for 11B, 11B. So 11B. Okay, for the C, so first you can break here, can break here. Okay, so and then you can expand. Okay, expand this equation, then you can simplify using the rules or the Morgan. Okay, so maybe I just share the answer here for question C. Okay, at the end you can get the CD plus AB. So this one after you have to double check lah. Okay, for D, so the last answer will be BD. Okay, BD plus DE plus D bar F. Okay, D bar F. Alright, so this is the answer for this one. D. For E, okay, for E will be CD. Okay, CD. Simplify if you get the CD. And then the last one will be A, B, C. Okay, so this is the answer for the question A, B, 11F. Okay, 11F. Right. Okay, so maybe I'll try another one lah. Okay, for 12. Okay, for 12, right, convert the following expression to the SOP. SOP lah, sum of the product form. Alright, so maybe first we can expand lah. We can expand this one. We can expand this. Okay, so you can expand this one to this one, and then simplify, and can get the simplify using the rules. Then you can write the in the SOP lah, in the SOP, not standard. This is the SOP form. So the answer will be AB K plus CD. So then for B will be A plus BD. Alright. And then for C will be AC plus B bar C. Alright. So for D will be A B D. Okay, A B D. Alright. So this is the answer for 12 D. Alright. So I stop here. Okay. So next I will continue on the video for tutorial. Okay, for tutorial 2 part 2 lah. Will be continuing from the question 15 until the 24. Right, so thank you very much. See you for the next video. Okay, assalamualaikum warahmatullahi wabarakatuh.